Okay, so
Thanks.
try, yeah, no problem. Let's try that again. So it should have been this. So this is 10 degrees north of east, right? And it was 266.67 kilometers per hour. And that's my ground speed. Now, it's flying, this is the hard part, right? The way this question's worded. I don't normally word them like this, but if there is a wind from 40 degrees south of east, so from 40 degrees south of east means it's blowing 40 degrees north of west. Okay, so I go like this. That's 40 degrees. And the velocity of the wind is 40 kilometers an hour. Perfect. Okay. So to get my velocity of the plane now, I have to go this minus that, right? You follow me so far?
Yep.
Okay. So I'm going to redraw these things. I'm going to draw this one this way. So that's 10 degrees. That makes this 80 degrees right here. I want to draw that in there. Okay? We're okay? My relabeling of that? All right? And I need to draw the negative of the wind. So it's going this way, right? So I'm just going to do this for right now. Degrees right there, right? And this is the negative velocity of the wind. This is the velocity of the ground. And this is my velocity of my plane. So far, so good? You following that, guys? Okay? So now it's just a case, how do I find my angles now?
Wouldn't the one at the top be 80?
Okay, so
Like,
if I drew this down like this,
80.
that's 80 right there, right?
Yeah.
Yeah, I agree with that.
40.
And then this makes this one here.
50.
50. So that whole angle is,
How is that 80?
The 90 minus the 40?
right, it's complement of this one.
Because it's a 90.
Oh, yeah, my bad. I was thinking 180. Yeah, never mind. I got it.
So that angle right there in its entirety is 130.
Yeah.
So now I can find, using my law of cosine, so let's do that. So that's, so 266, so square rooted, right? 266.67 squared plus 40 squared minus 2 times that times 130, the cos of 130. You don't need brackets for the,
Yeah, I might go.
no, the first one will open a bracket, and that's the only one you need.
And you just put it all in one
Yeah.
bracket.
Yeah.
So go sit, and then
No, okay, hold on, let's do this again. Get clear. Okay, so square root.
2 times 266.
Let's open the bracket, and I'll just put it in. And so this squared here, 266.67 squared.
plus
40 squared, yeah. Minus 266.67.
times, is it times? Yes.
Yeah. Times 40 times the cos, 130. So now you gotta close two brackets. And then hit equals.
What are we trying to find here? An angle or?
The side line.
Oh, so 293.
Which, yeah.
293.9.
Yeah.
93.
93.
83. Yeah.
Perfect. That's the right answer, right? Okay. So when I look at the question,
And then they want the angle.
yeah, I'll get the angle in a second. That's right. But when I look at the question, the first thing I need to ask myself, do I need to go faster or slower based on the information? Well, I want to go in this direction, and the wind is going in that direction. So do I need to fly faster or slower in order to get there on the time I want?
Faster.
I need to fly faster. So am I flying faster than if there was no wind?
Yeah.
Yeah. Right? So that's a good part of it. Now I'm going to get this angle here. So I have sine alpha over 40 is equal to sine 130 over 293.983. We have to talk about that angle once you find it. So find that angle first.
So you'd go 40 times sine 130.
Yeah. Second function sine too, right?
5.983, is that right? I don't think
Yeah,
so.
I think so.
Oh. Okay, so when you go second function sine 130, you don't close the bracket after 130. You put.
You should, yeah.
Why wasn't
You
that
close
angle
that
like
bracket.
Because it's not a
Because
90.
it's not an exact 90, look at the space underneath it.
Yeah, I got math.
Do you need to find another angle too, or no?
Okay, let's do this again.
No, because subtract.
Okay, it's second function sine.
Yeah, I know, but like,
Okay, and your calculator does it all. Okay, so second sine. Perfect. 40 times sine 130. Close one bracket. Yes, yeah. Close bracket.
See, I did it.
Okay.
Where do you have to put the brackets when you punch it in? I got the wrong answer.
I'm gonna use.
What'd you get?
283.811.
So what you did is you found, I'm not even sure to be honest with you. So what I would do is, okay, so
I'm
punch this
wrong.
in.
I might be wrong.
Second sine.
Or no, I got that for the coast one, sorry. Like for the.
For when we found the side.
This guy?
Yeah.
Okay, so
brackets for this.
square root, it opens a bracket, right? So now just put everything in as is, and at the end, when you go cos 130, you close.
Okay.
And you get the correct answer. Okay, so what is the direction this plane has to fly then?
You have to subtract that from.
4.017.
Okay, I want you got to give it to me in the direction, okay? Because there's two possibilities, right?
Well, I did it from the east. East 4.017 degrees.
Or north
Okay.
85. What?
0.983.
0.
Okay, so what's the alternative angle? North, 85.983 to the east. Either one works. Did you get it, Ian?
I'm the right thing.
Wait, where did you get the 4 from?
You take 10 minus 5.93 because we find it.
Calculator was on raise.
That's what happened when my son usually dropped his class on the back of the board.
Oh.
Yeah, it'll go back to it. So there's, I just hit enter first.
And we took that away from
Well,
10?
yeah, like from this, so this, okay, so the flight path of the airplane is either that or this. And so this angle comes from taking 90 degrees and subtracting these two right here. Okay? Or I could have done this and added those two together and made it north 85.983 east.
I think the answer's wrong.
No.
01. I think it's 017.
Yeah.
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 01
Oh,
here.
yeah, it's
01.
Good job, Alex.
No. That?
No.
No, 017.
4.017.
Oh, 017, okay. Yeah, that makes sense. Sorry, I wasn't looking 17 from that, yeah. Okay. Questions? Again, hard part in this question, or easy now, depending on how you look at it, I drew my two vectors, right? Then I took my ground level vector and I subtracted my wind vector. Put them on top of each other, and then all I'm using is law of cosines and law of sines. Question's done. Okay? Comments, questions, concerns? No? Okay. Anybody, you want to see anything else on this pages? So like if you look at the sheet, you have an acceleration question, which you have the change in velocity. You have an airplane question, in which you add the vectors together. You have the river question, and then you have an airplane question in which you subtract the vectors. That's basically all there is to this section. So you'll have 2 questions of each, and
Once you get this close to done, you should be know if you're good or not.
I dare you. You want to, what did you remember? 7 on the last page. I think that's the number it is.
plane's velocity changes from 400 to 500? Yeah?
Yeah.
Okay. So he's flying at 400 north.
Changes. Then he changes to 500 north, 40 degrees west.
Now you'll notice, when I do plane questions, I very rarely switch it over to right angle trig. Very rarely do I do that. I mean, you can do all these questions by right angle trig. Like I'm going to explain because of this one. But like this one here, you could have found the components of this guy. Found the components of this guy instead of putting where it was west and north, and changed it to south and east and done it. And you could do it without the law of cosines. If that's what you like to do, 2 vectors, find the components, draw a third triangle.
So just like the one question where there's like 4 triangles,
Yeah.
but it's only 2.
Yes.
Oh, that would make those questions so much
Yeah.
easier. I hate doing that.
Be a lot more work.
Okay, how about I come back to this after the next question then, and I'll show you how to do it the other way. Okay, so this question here, I got V2. So V2, right? I need the acceleration, so I gotta go V2 minus V1. So I draw my V2 first. So I've got it drawn right there. Actually, I can just add on now. Because what is the negative of 400 north? 400 south, right? So I would just do this, like that. And I want, this will be my change in velocity right here. Okay, that's 40 degrees. That's 400. And law of cosines, and I can solve that question.
How come that's not 90 there?
This is 90 right here. This is 40 there though.
Okay.
It's the angle between them.
Yeah.
Does that make sense to you?
Yeah.
Okay. All right. So square root 400 squared plus 500 squared minus 2 times 400 times 500 times the cos of 40.
321.8.
842.
I believe.
Thank you. Okay. And then I need to find that angle right there. So I've got sine alpha over 400 equals sine 40 over 321.842.
It's 53.
No, can't be the 53, I don't think. It's a little 5.
Oh, that's what I
How do
thought.
we get 321?
You can't, you get
Law of
because that
cosines.
will be more than,
I don't
although,
know.
what if it's more than 90 degrees?
Let's check this number then. Let's check that number, because that can't be. If this was 53, that means that that angle, oh no, sorry. Yeah, it could be. My bad.
That's what I thought.
Yeah, no, you're right. It is. sorry about that. I assumed, don't ever assume anything. I'll tell you why. Okay? This actually goes down here.
Oh.
So that angle can be greater than,
So it'd be like
So what
just over now.
right, so what, no, it would be quite a bit over. So what did you have, 53? Oh yeah, so you're right.
53.024.
024. So I'm gonna add that on to, I would add that on. So this is 90 degrees right here, right? And you said this whole angle is 53, so this would actually be, this is gonna confuse everybody, but this is east 3.024 degrees south. Is that what you got?
I don't
You
know.
had 53 in here, right?
Yeah,
Okay, so 40 plus 53 gives you
93.
93. So this little part right here is only 3 over 90. Okay?
And why is that east?
Well, it should be west. Next one.
Yeah, that was kind of
Yeah, west 3.024 is south. So, yeah, go
Where
ahead.
did the 3 degrees come from?
This whole angle right here is 53 degrees,
Okay.
right? Add 40
Yeah.
gives you 93. So from
On the
here to here is
90
90.
Okay.
Add on 3 degrees. So it actually went past where it was. Okay? All right, sorry about that. I messed that up a bit.
Sorry.
You understand what happened there then? Okay? So, any other questions about this guy? I'm going to go to that last screen and show you how to do it the other way. There's not? Okay. Okay. I don't want that. Need this guy here and this. Okay. So let's look at this. I'm going to look at this previous question here. So the velocity of my ground was, the ground speed was 266.667, right? And I got an angle of 10 degrees right here, okay? So take the sine of 10 and times it by 266.67.
And we'll get the far side.
I'll get the north part of this.
46.307.
Okay? Now take the cos of 10.
307.
307. 307. Okay. Take the cos of 10 and times it by that number now.
So really, it's the same thing. You just do like right triangles with the wind speed, the ground speed, and then you make one triangle with two.
Exactly.
Why'd you do cos?
Oh, yeah.
Oh.
I need this side right here, right? So cos 10. What did you get?
45.603.
Too low.
I don't know that. That's what I got too.
It goes 10 times 46. Or do you
Really?
want? Yeah.
Cos of 10
Mhm.
times 266.67.
Oh, you said 46.
Yeah.
You said times 46.
No, times that number.
2. That's 262.61.
I should just do sine with
That's
that
why-
too.
6 what?
Yeah, you
61.
It's just one extra step.
9.
I like doing sine.
Yeah.
So I would go.
Okay. So, I heard that question, I'll answer that in a second. So the sine of 10 gets you this side, right?
Yeah.
Opposite over hypotenuse. The cos of 10 times that gets you this side.
You
Okay.
could use sine though.
The sine law,
Oh,
Like-
you don't have the other angle.
It's-
Yeah, you do.
Yeah, you
See,
do.
I can get all three angles, so you could just use sine law.
you could. You can. If you like the sine law, no problem.
I enjoy this.
Understand it.
Okay. All right, so I'm just going to put this down here now. So my velocity of my ground, I have 262.619, and that is in the east direction, right?
Yeah.
Okay, and then I have 46.307, and that's in the north direction. So far, so good?
Yeah.
Okay, now I'm gonna look at this here.
That's 40.
That's 40 degrees, so I need to find out what this guy is right here and right here. So That's 40 degrees and 40 kilometers an hour. So sine 40 times 40 is what?
25.712.
Okay, and right now that's north, right? And then this guy right here, cos of 40 times 40,
30.642.
and that is,
That's west.
that's west, that's right.
I just need to grab Morgan Woodman's calculator.
Okay.
She's at the back table somewhere.
Yeah, I
Yes.
think that must be his stuff. It's right above.
Oh.
Okay, so, but here's the thing. So we are able to do it this way. Now what has to happen is, my wind is actually in that direction right now, right? But I need the negative of it. So when I put it onto my chart, I'm going to switch those two directions.
That's what's gonna mess you.
So this here is now 25.712 instead of north, it is
So,
south. And then this is 30.642, and instead of west, it is east. Okay, now I add those together.
So like that every time.
If you're subtracting, like the ground speed, subtract the wind speed, yes. Yes.
So if it's a
And you
person
have to do that
walking,
every time there's
but if it's a person walking, you won't subtract it, right? Like if they're walking one direction, then they switch to the other?
Yeah, right. Like that question with the 4 vectors,
You
they're
don't
all,
have to do
you're
that.
not subtracting any of those vectors, you're just adding them.
The one with the swimming though, you'd have to do that, right? Because the wind is pushing.
Yes. Yeah. Okay. So let's solve it now, right? I got 46.307 subtract 25.712. What does that give me?
20.595.
20.595, and that will be north, right? Because that was the bigger one. And what's the next one? So I got to take this value, add it to that value. So that is
293. That's
291.
293,
6, and then 293. That's
Yeah.
all 261.
261, and that's going to be east, right?
Yeah.
Okay, so let's draw those vectors out. There's my north. Oh, I don't want to do it over on this side because I can't draw the east then. So I'm going to draw my north right here, my east right here, and that's going to give me my plane's velocity right here.
How do you know which way to draw it? Like, how do you?
Doesn't matter.
It doesn't. Just
Doesn't matter.
as
It's
long
just, I'm going to get the complement if I draw it the other way, the complementary angle.
Yeah, so the east, north instead of north.
Yes,
And I can
exactly.
right either way.
Yes, yes. Okay, all right, so I've got, but I don't have room to write these in, but this squared plus this squared and take the square root of it. And that'll give me what my plane speed
as
is.
we have to right triangle.
Yeah, exactly. It makes everything.
Oh, that
easy.
is like.
I hate that other stuff.
Love that rule.
It's the same amount of steps because you have to find like more angles, like well not more angles, but different types of angles in that one. Like
That is a lot more confusing than that.
Okay, so what did you get?
293.983.
983 kilometers per hour. What did I have over here?
Same thing.
Same thing. Now, where this has the benefit is calculating the angle. It's way easier to calculate this angle right now. So now I have this side, which is 293.261. I have this side, which is 20.95. So now what I want you to find the second 10 of 293 divided by this. So take 293 divided by that. That 293 is up here. So it's the opposite angle. 20.595 is right here. So second function 10, what is that?
85.98.
I'm just gonna do sign.
85.983
That's all I do.
degrees east. Is that what I got on that board over there? Yeah, got the same answer. So, Rowan, to answer your question, had I drawn this east and north, I would have got that angle.
They're both right. So, but the
So it's the same.
85 is right.
They're both right. They're both right because they're clockwise.
I
Yes.
kinda do.
Okay, thank you.
Oh, Mr. Newton, you earned it after being such a good sport.
That's right, there's not enough for everybody in here, so. Okay. You guys like that better than you said?
Oh, but like, it's,
Some people do some.
No, so
people
that's
fine,
fine.
like, since that is 80, well, you can make it sign, right?
Do you sign and you
Because
use
that
this, and this, as long as you've got this right,
Yeah.
if you didn't make an error and you got this right, then it'll work with sign or coast or tan.
We can do the same thing for number 7, right?
Yeah.
But you don't have to take it away because there's no way.
Okay, well, if I was to do number 7 now, this one, I basically did it. Yeah, sorry, let's do it, okay? So what I would have done here, is this, right? And 40 degrees right here. So I would go up and over, and it's 500. So I would put that in there. I'd find sine 40 times 500, okay? I do cos 40 times 500, and then instead of having a north angle here, I would end up with that guy being a south, right? So this would be a north, and then west, right? And then the top guy would be a south, and you do the same thing, right angle trig.
So for that one, you have to switch.
Right,
it.
All right? Yeah, I don't want to take too much more of your time. I don't mind answering questions, but if you need to battle through a few of them on your own, and then if you need help, ask that way. Okay? So, like I said, I don't care. The only questions that you have trouble changing into this is the ones where you're given the plane speed and you have to go into the wind.
We have to make it negative.
Or into the current.
Yeah. No, the current is fine. It's the wind one where they give you the plane's velocity and you add on, and you're going into the wind. It's okay if you have velocity of the ground and velocity of the wind and get the plane or vice versa, but when you have to add the plane and the wind together, it's a little bit harder to do. But they can all be done with right angle trig. Yes. Okay? So go back through some of those questions then and attempt them with right angle trig and see if you find it easier. Okay? All right. Go ahead and work through the rest of them.
Right angle trig.